This is Prototype 1 of Group G1 for the biomimicry inchworm rover with our swamp and deck. For the electrical system, we plan on using a manual controller to control the inchworm, but because the unit we bought arrived broken, we temporarily hooked up an Arduino to move all the servos. And speaking of, there's supposed to be a turning servo in the middle, but it's absent because it wasn't good enough and the bracket was too weak. And furthermore, there should be a battery pack of 4 AA batteries, but unfortunately, by the time we tested, we used up all our batteries and we could not find new ones.
This robot was created upon the premise that it would mimic the movement of an inchworm. The movement mechanism was created such that the servo motors would open in order to push the front forward and close to drag the back up. At the same time, friction pads on the bottom of the robot were utilized to either allow a sliding or sticking mechanism, depending on which end of the robot was moving. Felt pads were used for sliding, and hot glue was applied for sticking. This motion can be seen in the video in the slide. These friction pads proved themselves to work on flat ground, but then when an angle was added to the robot, we ran into some issues. Mainly the fact the robot was too heavy and the pads weren't sticky enough to properly push the robot in a forward motion.
For our next prototype, we plan on using a material with a higher friction coefficient for the anchoring pad, as well as using roller ball bearings for the lower friction to replace the felt pads. We're also going to introduce a turning servo, which will sit at the top of the robot, in addition to redesigning the legs of the robot with a more rigid material that will also be more straight to promote better movement.
Hi, I'm Chloe. I designed the swamp system. So according to my system curve, the operating point for the green pump is approximately 10 feet. So for my minor loss section, I used a 1/4 mil adapter flow restrictor and added a section of 5/16 final tubing. And with that head loss section, it brought the system down to 1.5 gallons per minute. And my low flow pump is up at 1.5 gallons per minute, which is just where we need it to be. And then for my black pump curve, the operating point of the system was at approximately 17 feet. So for my minor loss section, I added 1/4 inch latex tubing, and then that wasn't enough to bring down the head loss. So I added some flow restrictors by using 5 millimeter O-rings on the latex tubing to add for extra minor loss. That brought the system down to 1.5 gallons per minute, which again, my low flow pump is at 1.5 gallons per minute, so just what we need it to be at.
Hi, this is Karsang, and this is a driving Drake Prototype 1, and this was the testing day 1, which I failed. Now this one is the new deck that I built for the next day on Friday, and it's a combination with joist and beam, and I ran the calculation in an Excel file. This one is the new bridge, and I did the testing day on the Friday and with a bunch of load on the top of this one. So I put the concrete slab to see how stable it's on the ground, and it shows it pretty stable. So, and for the next one, what are we gonna do? Need the good combinations of the joist and the beam, and also like I'm gonna widen the size of the deck.